Today we will start with a new topic that it's called radicals. It is also known as roots, but the mathematical name it's radical. Remember that a root or a radical it's the opposite mathematical operation than an exponent. So radical is going to be the opposite as an exponent. Let's see the parts of a radical. We have it here. We have a number outside that is multiplying the radical, so we can call it the coefficient that it's multiplying the radical. The radical will have different parts. This little number, it's called the index, that it will tell us the value of the root. If it's a number 2, it's going to be a square root. If it's a number 3, it's going to be a cubic root. If it's a number 4, it's going to be the fourth root, the fifth root, etc. What happens next? What we have inside of the radical sign, this one is going to be the radical sign. It's going to be called the radicand. Then, of course, it's going to be a mathematical expression. It can be a monomial or it can be a polynomial. And the m, of course, it's going to be the power of the term that is going to be, or the terms that are going to be inside the radical. What happens here? When m it's bigger than n, that means the power of the radical of the radicand it's bigger than the index. It is possible to take out factors from the inside to the outside part of the radical. We will see that topic in some minutes. Another important part for today's topic, n can have a value of 2. It's the most normal, the square root. So if we have a number 2 here, normally it's not written. We don't put a number 2 here, and we can know that it's going to be a square root. Remember, a square root, it's a number multiplied by itself 2 times. That gives me the answer. So what happens in the case of the radicals? We can have a pair index of a positive expression. That means if we take out something of this radical, our answer is going to be positive. It can be negative. Yeah, it can be negative because negative multiplied by negative, it's going to be positive. But now we will see only the positive part. What happens if I have an odd index? An odd index, that means we will look for a number multiplied maybe 3 times by itself or 5 times itself of a positive. It's going to be also positive. Why? Because if we multiply positive times positive times positive, it's still positive. What happens when we have an odd power but for a negative expression? It's possible that it's going to be a negative answer. Why? Because let's see 2 different. An odd number, it's number 3, for example. So if it's number 3, it's going to be number multiplied by itself 3 times. So that will give me negative multiplied by negative, it's positive, multiplied by negative, it's going to be positive, negative. So that's possible that this one can be a negative number. What happens also? If this one, it's an index of 5, that means it's going to be a number multiplied by itself 5 times. That gives me that one. Negative multiplied by negative, it's going to be positive. Multiplied by negative, it's going to be negative. Multiplied by negative, it's going to be positive. Multiplied by negative, it's going to be negative. So if we have an odd power or an odd index of a negative term, the answer is going to be negative. Of course, we cannot have pair of a negative. Why cannot have a pair of a negative? Because if it's number 2 negative multiplied by negative, it's going to be negative multiplied by negative, it's positive, so it's impossible. If we have another pair like 4, it's going to be negative times negative, it's positive times negative, it's negative times negative, it's positive. So it's not possible to have a pair index of a negative term. So these are our possibilities. Pair index with a positive, it's positive. Odd index of a positive, it's also positive. And odd index of a negative, it's going to be negative. Of course, here cannot be positive also, because positive multiplied by positive multiplied by positive, it stays positive, cannot be negative. So these are the three that we can have. For what happens with simplification issues, it's going to be very simple. We need to factorize the radicand. If it's a monomial, it's going to be prime decomposition of the numbers. If it's a polynomial, we will need factoring. What do we need to do next? We will do a little division. The power of the radicand, factorized, divided by the index of the root. What happens? The number that gives us the division will be what we write outside the radical. The remainder, if the division has a remainder, it will stay inside the radical. So let's see actual exercises. We will start first with those when m divided by n, it's an exact division. And after that, we will see when m divided by n, it's not exact division, that it's when we will have a remainder. Let's see some examples. So we have the fifth root or the fifth radical of 32. So first we need to decompose the number 32 to 8, to 4, to 2, to 1. That means this one we can write it as the fifth root of 2 to the 5. So if we divide 5 divided by 5, it's 1. So the answer of this fifth root is going to be only a number 2. So that's a simple exercise of how to do a radical simplification when m, the index, and the power of the radical are an exact division. Let's see another exercise. So we have the fourth root of 16 m to the 8. So we need to decompose the 16 to its 8, to its 4, to its 2, to its 1. So this one we can write it as the fourth root of 2 to the 4 and m to the 8. Remember, we need to divide the powers of our radical with the index of the root. So 4 divided by 4, it's 1. So it's going to be only 2 to the 1. What happens with the m? 8 divided by 4, it's going to be exactly 2. So the answer of this specific radical or root is going to be 2m squared. Let's see another example. So in this example, we have a negative term, but the root is an odd index or has an odd index. So it's possible, remember, when we have an odd index of a negative, we know that our answer is going to be negative. So what can we do here? It's going to be, we decompose the 125. So it's going to be 5, 25, 5, it's 5, 5, it's 1. So this one is like having the cubic root of minus 125. I'm sorry, I repeated. It's 5 to the third. That multiplies x to the 9. So let's do the division. We know that our answer is going to be a negative one because it's an odd index of a negative term. So it's going to be 5 to the 3 divided by 3. It's going to be only 5 to the 1. X is going to be 9 divided by 3. That is exactly 3. So it's going to be the answer minus 5x cubed. So it's going to be very, very simple. It's only in the case of monomials, we will need to prime the composition of the numbers. And after that, we will do the little division of m and n, and that will be the answer, what we take out of the radical. Let's see another example. So in this example, it's going to be a little bit different because we have a coefficient different than 1. but it's going to be also very simple. Remember, we will decompose the radicand. So it's going to be divided by 3, 81, divided by 3, 27, divided by 3, it's 9, divided by 3, it's 3, divided by 3, it's 1. That means this one we can change it to minus 2a, that it's outside. The inside part is going to be changed to minus 3 to the 5 multiplies a to the 25. So remember, what will happen here is that we have the minus 2a, that it's already outside the radical. What happens with the radical, it's negative of an odd index. We have an odd index that it's 5. We have a negative inside, so our answer is going to be negative also. What happens next? 5 divided by 5, it's going to be only 3 to the 1. 8 to the 25, it's going to be 25 divided by 5, it's exactly to 5. If we multiply those, minus multiplied by minus, it's plus. 3 times 2, it's 6. 8 to the 5 and 8 to the 1, it's going to be 8 to the 6. And that's going to be the actual answer. Let's see other exercise. So here we have fractions, but don't worry, it's going to be exactly the same. So what happens here, of course, what it's outside the radical, it's the coefficient. Inside the radical, we need to change it. We need to decompose the numbers. 81, 327, 39, 33, 31. So this one is going to be 3 to the 4, y to the 4. 4, it's 2 times 2, or 2 squared, x squared. Remember, when we don't have an index here in the root, when we don't have an index, that means it's like having a square root number 2 here. So it's like having a number 2. We don't need to put it because it's going to be incorrect if we put it, because normally we don't put it if it's a square root. But let's put it here for explanation purposes. What happens is that we have 2x divided by 3y squared. And let's see what we can get outside the radical. Remember, we need to divide the power with the index. So 4 divided by 2, it's 2. So it's going to be 3 squared, y squared, all of it divided by 2 and x, because 2 divided by 2, that is 1. 2 divided by 2, that is 1. What will happen here? We have a multiplication of rational expressions. 2x with 2x can disappear. Y squared with y squared. We have 3 squared and 3, so we can take out this one with this one, and our answer is going to be 3. I'm sorry here I committed a mistake, because actually here it says y to the third, not y to the 2. So it's going to be y to the third, y to the third. So what happens, it's going to be only a 3 on top and a y on the bottom, and that will be the answer. 3 divided by y. So it's very simple. It's only using the prime decomposition, and after that taking out what we have inside the parentheses. If we have a coefficient outside, what we take out of the radical, not the parentheses, I mean from the radical, it's going to be a radical, a rational expression multiplication, and we can simplify it. Let's see another example. So if we have a polynomial, it's going to be almost exactly the same. In this case, the polynomial, all of it, it's to the 12th power. The index, we don't see it, but it's a number 2. So it's going to be 12 divided by 2, and our answer is going to be 2x minus 5, all of it to the 6. So it's going to be also very simple when we have powers with the polynomials. It's going to be exactly the same. We divide the power of that polynomial with the index, and that's going to be the actual answer. Let's see another exercise. So what happens when we have a polynomial but not a power? Remember, we need to try to factorize that polynomial. So this one, we can put it a little bit different. This one has a square root that it's 5x. this one has a square root that is 1. If I multiply those times 2, it's going to be the middle one. So that means this one, it's a perfect square trinomial, so we can put it like 5x, the sign of the second one, minus 1, all of it squared. So what I can do now, we have a polynomial to some power. We can divide that power with the index of the root. 2 divided by 2, it's 1. And on this one, the answer is going to be actually 5x plus 1. We can like not put the parentheses. We don't need it now because it's to the 1. So the answer is going to be 5x plus 1. Let's see one last example. So on this one, what can we do? Remember, we need to factorize what is inside the radical. So it's going to be, first, we can take out a 4x to the 4 as a greatest common factor. So it's going to be x squared minus 2x plus 1. After that, we can factorize again what is inside the parentheses, and it's going to be 4x to the 4 that multiplies x minus 1, all of it squared. We have factors now, so we can see if we can take out some factors. Number 4, we can decompose it, and we can put it like 2 squared x to the 4, x minus 1, all of it squared. So let's see. We can now do the division of the powers with the index. Remember, this one is a square root because we don't have an index. So 2 squared, 2 divided by 2, it's 1. So it's going to be 2 to the 1. X to the 4, 4 divided by 2, it's going to be 2. And the parenthesis part, x minus 1 was to the 2. So it's going to be 2 divided by 2, it's going to be to the 1. And that's going to be the final answer. So we see in today's video that when m divided by n, it's an exact division. It's going to be very simple, only factoring or using prime decomposition and doing the simple division to take out whatever we can take out of the radical sign. Let's do the next video that is going to be when m and n, it's not an exact division. So let's go to the next video.